Okay, we're given a curve. The equation is f of x, but look what we're given. We're given dy by dx. Okay, this is familiar. We're given a point on it, so we're given an x and a y, and we want to know what f of x is. So we're working back from dy by dx to the original function f of x, so this is integration. This is what I need to integrate, this term in the middle, okay, the 5, well, it's a minus 5 over root x, okay. I need to think, well, fraction with numbers and a fraction with x's, but the fraction with x's in it, you can turn the square root of x to a power of x first if you like. This is going to be a single power of x. We want this term here to look like minus 5x to some power. And to find the correct power of x, you've got to use the fact that 1 overness, we need a negative number, and the fact it's a square root means we also need a fraction. So this is going to be a negative fractional power. This will integrate nicely. Add 1 to the power, divide by the new power. This will integrate, add 1 to the power, divide by the new power. The power here will be a fraction, so to divide by a fraction, you turn it upside down and multiply. To integrate a number, well, that happened in the first question on this paper. Remember, it doesn't vanish, it becomes x's. But do not forget your plus c. So having done your integral, set this up as an integral, get your 3 terms plus a c at the end, and then this is your y. To find out the plus c, you substitute your x and y values in, and you get a value of c after you've solved an equation. You do not get the 5th mark until you write out your full equation for y again, with this plus c at the end replaced by the actual number for c. And then we've got an equation of a tangent, so that's a trigger phrase, and a tangent is a straight line. So once again, we need a point and we need a gradient for the second time on this paper. Okay, so a point and a gradient, well, we have the point P, we've got an x and a y, so the point's easy. The gradient, how do we find gradient? Well, this time it's not the 2-point method, it's dy by dx tells us a gradient. So I take my x value and I substitute it into dy by dx, and I get the dy by dx value for that particular x, and that's the gradient. Do I need to adjust it? Well, the tangent has the same gradient as the curve, so I don't need to make it perpendicular. So my point and my gradient, I go straight to the y minus y1 recipe, and I make sure my answer's in the form they say. Done.